wanted to kick things off. Oh yeah, I didn't introduce myself. I'm Michael Bates. I work here at MakeTime. I've been a professional developer for 3 years. I've been here for a year and a half. That's it. I don't know. So I wanted to kick things off in Rubyland by doing things very different than you normally do them in Rubyland. So sorry if this is your first go at it, but I wanted to, because I've personally been learning a lot about functional programming over the last year or two, and I've been learning how to kind of bridge the functional world into Ruby, which is a more traditionally object-oriented world. And so I wanted to share some of my lessons. And I want to start out with sort of giving a little definition. The term functional here refers to the fact that we're using functions as the main unit of composition and abstraction. This is sort of in opposition to using objects as the main unit for those things, like we normally do in object-oriented programming, right? It's right there in the name. And those seem like they're in pretty direct opposition. The functions and objects, they feel like pretty different things. So how do we do functional stuff in a place like Ruby where it's all OO? So first I want to show just a little snippet of code, like how do we normally do these things, right? So we might make a little dog, and we might compose a dog out of a name, an age, and a breed. And we might give him a method like this called bark, where he can speak his name. So dog here is composed of these other three properties. And this is nice because we can just sort of encapsulate these three distinct properties in one thing. And we sort of abstract over it that way. And we just treat it like a dog. So we can say, hey dog, what's your name? We can tell him to bark, things like this. All right.
Bosco.
Oh, I named it Bosco, right? Silly me. Right. So this is how we interact with objects normally, right? And you're probably used to this, even if you're not from Ruby. This is pretty standard fare. But there's always a little more to the story here, and Ruby is one of those languages that really lets you dig in and do whatever you want with stuff. So I don't know if you know this, but you can actually get, for example, like you can get straight, you can grab methods off of objects. So if we wanted to sort of grab a reference to that bark method, we could do that like this. And we can maybe put this into another variable. And then we can call it. And now this bark method can kind of live beyond Bosco himself, right? So this is kind of a neat thing. Something else we can do is actually get that same method from the class itself. And this gives us something slightly different. It's not a method, it's a thing called an unbound method. And if we try to call this, it doesn't work. It kind of blows up in our face. And there's a reason for this, but I'm going to kind of come back to that later. So this is just a little warm-up thing. So I want to do a quick diversion and kind of double back on what some of the differences between functional and object-oriented stuff is. So we got a little historical diversion. Does anybody know, pop quiz, who this guy is?
Turing?
Who is it? Yeah, it's Alan Turing. Alan Turing is a notable notable mathematician and computer scientist. He's most well known for, well, he's known for a lot of things, but one of the things he's known for is what we now call the Turing machine. The Turing machine is it's a hypothetical machine that can compute anything that's computable. It's like a very procedural way to do computation. It's basically a CPU that's like, any computers these days are like concrete implementations of what a Turing machine hypothetically is. It also gives us a sort of definition of what kinds of things are computable. So that was a really big advancement. This was way back in the day, right? This is before computers were really a thing. He had a peer. Does anybody know who this guy is? He's a little less well known. His name's Alonzo Church. He's a peer of Alan Turing. He's also a mathematician. And he invented a thing that's known as lambda calculus. And lambda calculus is interesting because it's another definition of computability, the same kind of thing that the Turing machine is. The difference is that lambda calculus is a sort of notation that's defined in terms of functions. And where the Turing machine defines computability as a sort of like procedural step-by-step thing, lambda calculus, as the name implies, is a much more mathematical concept. It's a lot of composition of functions and things like this. So these two things seem really different. But as I said, they were peers, and they actually have a thesis together, and it's called the Church-Turing thesis. And the Church-Turing thesis says that the Turing machine and lambda calculus are, although they're different ways of describing it, they're both equivalent definitions of computability. So anything a Turing machine can do, you can describe in terms of lambda calculus. And anything you can write in lambda calculus, a Turing machine could compute and do. So maybe that's kind of obvious because we have languages today that are like purely functional, like Haskell, and those are basically implementations of lambda calculus, and they run on computers which are basically Turing machines. So maybe that's totally obvious. But what I think is cool is, and what this tells me is that for any pattern that we have in object-oriented land, there must be some equivalent pattern or technique we can use in functional land to achieve the same results. So what I want to do the rest of the time, that's enough of these guys. What I want to do the rest of the time is sort of bridge the gap between these two worlds, and hopefully make them seem a little more approachable. Okay, so back to our dog, Bosco. We are trying to use this unbound method. And you might be asking, why would we do this? We'll come to this. But first, how do we actually make this work? So we can't call this unbound method, but we can bind it. So if it's unbound, let's try binding it, right? If we do that, we actually get a method out. And if we try to call that method, then we get Bosco's bark. So that's kind of cool. And if you sort of squint at this, like it kind of looks really similar, these two methods here, bind and call. And we can actually sort of do that if we squint here. So here's me squinting. So we can actually make this method call on unbound method and just have it take the instance in and then bind to it and then do a call. So that's kind of neat. So we extended unbound method to do a thing that it couldn't do previously, which is neat. This is something that Ruby lets you do all over the place. And this is cool because we've now like taken this abstract bark function and we made it a little more concrete by giving it Bosco. And it looks exactly the same as this, but it's sort of been flipped around. This kind of technique is useful, especially for things like dependency injection. Oftentimes you want dependency injection is when you maybe you have like a logger or you have an analytics engine or something, and you want to write the logic in your application so that it sort of ignores the fact that you're using these dependencies up until it really needs them at the very end. And using this kind of technique, we can do that with this thing that's called function currying. So this technique of, let's call a method but with like partial arguments. So here is a little example method. It adds 3 things. You could call it like that. And we can, of course, get a reference to that method directly. And we could call it the same way, but we can also call this method curry. Okay. Copying and pasting. And when we do this, what we actually get is the ability to call this method 3 different times, once with each of the arguments. And when we finally give it the last argument it needs, we get the result that we're looking for. So you can imagine that if this were something like, I don't know, a logger, then we would want to do something like this, right? And so this is the core of what our method is doing. But it doesn't really do any side effects until we give it that last thing. So maybe if we had like some logger that did this stuff, then this would finally like print it out to the console or whatever, right? So that's function currying. My hope is like you can see how maybe this would allow you to build dependency injection or other kinds of things using this method. If you kind of invert the way that you call functions, you get these neat properties. Anybody have any questions about that?
I have a question.
Yeah.
So going back to your original example with bark.call.
Yeah.
How does it respond to duck typing? Like if you had a different, like maybe a cat object that would have bark method, could you call out an instance of that and get the result? Nope.
Like this?
That could have been really cool.
Like if we did that?
Well, I'm saying if the class has an instance of bark.
Oh, I don't know.
Can we try it?
We can try it. Let's do, instead of this, let's do a different method.
Mm-hmm.
So maybe we'll grab like,
Maybe like a name method or something?
let's take, what's the number class? It's fix num, is that what it is? Nope. Yeah, that's what I meant. So let's say we took the method from this called toS and yeah, like this. And we want to give it maybe like a float instead.
Mm-hmm.
Yeah. So, okay. That's all that. Anybody else have any other questions? Okay. The next thing I want to talk about are collections. So oftentimes we find ourselves doing operations on collections, those being like containers of other objects, right? So we might have a bunch of dogs, and we might want to turn all those dogs into an array of all their names. Oh boy. Right. So we get Bosco 3 times. So here we're taking a collection of one type, all dogs, and we want to turn it into another collection of another type, names or strings. And this is something that we do so often, just moving data from one place to another place, that we have a different way of doing this, a much more concise way of expressing this, and it's called a mapping. This idea comes from mathematics, from functional programming. Ruby collections have a very conveniently named method called map. So we could, for example, make a little method like this using this special syntax. And this little method's going to take a dog and it's going to pluck his name off of there. And we can get, we can tell dogs to map over itself using that method, and we will get the same result as above. There are many other ways to write the same thing. We can also write it this way using block notation. Oh boy.
Oh, it's all dogs instead of dogs.
Yeah. And we can also do it an even shorter way. This is all just syntactic sugar, but same thing. So these all do the same thing. But the idea here is that we want to, again, just transform a collection of one data type into a collection of another data type. So we can use map to do that really elegantly. I mean, this was like 6 lines, and down here at the end, this is the easiest way to do it. It's 1 line. It doesn't get better than that, right? There are a lot of other operations that can be written in terms of map, and there's a whole suite of them defined in the Ruby enumerable module. So if you want to make your own collections, you can do that. You just include enumerable, and it'll magically work. We don't usually find ourselves doing that, though. So I want to take this idea and go a little further with it, get a little more abstract, and talk about containers in general. Here I was referring to collections, right? It's a collection because it's a thing that holds a bunch of another kind of thing, more than one. But a container could just hold one thing too, or it could maybe hold a number of different kinds of things. So we can think about a lot of different kinds of containers. Here's a few of them. We have hashes in Ruby, which are a container of key value pairs. This is another kind of collection, sort of like an array, but with key value pairs. Strings are sort of like an array of characters. We can move through a string one letter at a time and process it that way. A file is sort of a collection of lines or just strings. So a file is almost, if we think of strings as an array of characters and a file as an array of strings, then a file is sort of an array of characters, which is interesting. And then this other one, which is not something we have in Ruby, but what we find in some other more modern functional programming languages, is a maybe type. And a maybe is something that expresses the idea of optionality. Something could be here or it could be absent. And in Ruby, we usually just use the nil value for this. But a maybe sort of takes it a step further. And so that's what I want to focus on, because I think the other things are fairly obvious. I think if you understand how you can map over an array, you can understand how you might map over a hash or a string or a file. It's all pretty much the same. But a maybe is kind of the outlier here. So let's walk through what this might look like. So we can use the struct initializer here to make a new type that just has a value. And then if we wanted to implement map on this, it might look like this. We could see if the value is nil, and if it is, then we would just kind of return nil, so to speak. But we're going to wrap it up in another maybe instance here. And then if it's not nil, we actually want to process it somehow, and that's what this yield value call does. And then whatever the result of this is, we're going to wrap that in a maybe and return that. So how does this work? We could do something like this, where we sort of have a value here called yay. And we can map over it. Well, here's what it looks like, right? So maybe, and it's got a value of yay. And if we want to capitalize that, we can use the strings method called upcase. And using our special map method that we made, we can sort of optionally upcase the string that's in there. But let's say that we don't actually have anything here. And maybe we want to try to upcase that, right? It doesn't blow up. It doesn't try to call that method. It just goes, no, there's nothing here, move along. It just gives us the same thing back. It gives us nothing back, right? This can be really useful, especially when you want to sort of be safer with your code. Ruby doesn't enforce any kind of type safety with the code that you write. So you oftentimes will end up with nil values just sort of popping up all over the place. A lot of things return nil if you have like an empty array and you try to grab the first element out of that array, you get a nil, right? So that's kind of stinky. And then maybe if we expected this to be a string, we might try to call upcase, right? But it's gonna blow up. We'll get a no method error on this. So if we wanted to be safer with this, we could wrap it in a maybe, right? Like there might be a first element in this array. And if there is, then we want to try to upcase it, right? So now it doesn't blow up, it just gives us nothing back. So that's nice, right? It makes our code a little bit safer at the expense of some verbosity, but this is like a really basic implementation. There's other features we could add to this class that would make it a lot easier to work with. And actually, so the cool thing is Ruby actually has this sort of behavior built in now. So we can call methods on objects like this, right, using the dot notation. And that's what this looks like. But if we try to do nil on this, we'll get a no method error. We don't want that to happen. We can actually stick an ampersand in here. And Ruby sort of implicitly does this map-like thing here, where it checks to see if this value is nil, and if it is, then it kind of skips everything after it. So that's pretty useful. So hopefully, by explaining all of this kind of craziness here, you can see how this maybe construct sort of matches up with containers in general. It kind of looks like an array, sort of an array if an array could only hold one value or no values. And hey, turns out we can actually do this in Ruby already. Pretty sweet little feature. Any questions on that? Anybody lost? Okay. So the next thing I wanted to cover is sums and products. And I don't mean just in terms of multiplication and addition. I'm actually referring to sum types and product types. This is a sort of categorization that we can apply to types when we think about them. And we can do some interesting things. These terms come from type theory, which is a sort of branch of computer science and mathematics. And its definition is it's an algebraic data type that's composed of other types. The thing that we're most used to is product types. A product type is a thing like a class or a struct, where it's composed of, some number of other things. The reason this is called a product type is because the range of all possible values of food here is all the possible values of ingredient times all the possible values of spices. That might be hard to visualize, but if you imagine these as like certain numbers, if this could only be like 1, 2, and 3, and if this could only be 1, 2, and 3, then the only possible values of food are the 9 combinations of 1, 2, and 3 here, right? Boop, boop, boop. So we could use basic numbers for these attributes, but in order to talk about what a sum type is, I have to sort of get into a different language here, because Ruby doesn't give us this ability right out the box. Well, actually it does. You know what? I'm just going to skip over this part. All right, fine.
You don't have to go into detail.
So in Rust we have, and also in C, we have these concepts of enums, which is a type that has a certain number of discrete values. So if we imagined our ingredients and spices, and these are the 3 ingredients and the 3 spices, then we can build a food out of any of the 9 combinations of these ingredients and these spices. So these are sums, because their possible values is just that plus that plus that. It's 3. Ruby doesn't give us enums like this in Rust or from C. But something that I learned kind of recently was that we actually do have a way to constrain ourselves to only a certain number of things, and it's actually through subclassing. So if we imagine this, if we take this idea and we want to just directly translate it into Ruby, how would we make an ingredient, right? If we only wanted 3 kinds of ingredients, we could subclass ingredient, and then those are the only 3 ingredients we can use, right? So instead of using like, you know, actual numbers here for these possible values, we could build a food like this. So we have to use an explicit ingredient, we have to use an explicit spice, right? This isn't like some string coriander, right? Because like, what if we misspell it? um, so using sum classing, we've constrained the amount of data that we could work with here. And, you know, I don't know what app this would be for, but I'm sure you can imagine a lot of cases where you might just quickly turn to a string to like type out some values for what you're thinking about in your app, right? I'm building some kind of, you know, shopping cart, and these are the ingredients that I can think of. You just type them all out in a string. It could become unwieldy. You can get typos. It's hard to validate that kind of stuff. But if you use classes and subclasses to create these sums, you can constrain the amount of data you have to work with, and you can think about, you know, your data types in a much more knowable way. You have to do less thinking about what could go wrong, I guess, is where I'm getting at with this. Yeah. We didn't add any behavior to these things, but, you know, if there was some kind of like name here, we might want to just like not implement that for raise, but then on all of these different things we could actually put the name of the food in here, you know, when we want to like go display this in the UI or whatever, right? And so we implement this for all these subclasses, and maybe there's some like behavior that's sort of shared between these different ingredients, like blend. Right? I don't know what this would do. But we could do something here.
Shove their names together.
Yeah.
It's like Corrado.
Mm-hmm. So, you know, we can share this blend behavior between all of our ingredients because they inherit, and we can override the things that are specific and important to these subtypes here, these subclasses. We get nice data modeling properties out of this. And it makes our program easier to think about. There's also like pattern matching stuff that you can do with this. So if you have like a whole array of ingredients and you want to do certain things with certain ingredients and you want to do other things with other ingredients, you can use like a case statement, for example, on some foods that we have. And, you know, when it's a potato, then we want to do a potato-y type thing, right? But, you know, we don't have to, like, treat these as strings, and we don't have to handle some default case where, you know, we don't know what kind of food this is, and, like, how did we get a missing food? I don't know. Food. Yeah. Anyway, I'm rambling a little bit. Does anybody have any questions about this stuff?
What's your favorite ingredient?
Squash? I don't know.
Would you
I made
prefer
squash recently.
Would you prefer carrot or potato?
Probably carrots.
Interesting.
Mm-hmm. That's the word. There.
Perfect.
I just had a question. So,
Yeah.
are Are case statements not often used? Use case statements all the time.
You don't see them very often in Ruby, and I don't know why.
Or switch statements.
Yeah. Did I? Oh, I see what I did here. There. Syntactically correct examples.
We don't use case statements that often in Ruby, so I just learned about them this week. But
Yeah.
they're pretty cool.
They are pretty cool. It's, I don't know, it's really useful when you have something like this, right? You have some kind of data, and you have a whole bunch of different kinds of that data, and you're processing, you know, a non-homogeneous collection of those things, and you want to like break out certain behavior in certain cases.
Yeah. So when it's just like choices that you determine already, not something open-ended.
Yeah.
Yeah.
I think a lot of times you'll see people like, they might just implement this like favorite method for like all of the various subclasses, and then they'll just be like, oh, well, I know that all of my foods have a favorite method, so we'll just do that. And that works sometimes, but sometimes you add a new ingredient and you forget to add the default favorite property to it, and so then that one part of your app that you forgot to test breaks. So I don't know.
Or they, all of those ingredients inherit from like a vegetable class that
Mhm.
always implements.
This always returns false.
Yeah.
Yeah, and we could actually provide a default here, right? For all the ingredients, we could just say by default is false, and we can override it for certain ones.
I think that really gets at the heart of like object-oriented versus functional, is that there's a way to do everything everywhere. It's just like how much typing do you feel like doing in this one, or how much restriction do you care about in the other one.
Mm-hmm.
There's always a way to do it, and some are better. Object-oriented is better at like really opening things, and functional is way better if you know exactly what your data looks like, and you just want to like get it out there as fast as possible. Hopefully.
Yeah, that's a good interpretation. Yeah, I think the sort of philosophy behind object-oriented design is have the things know how to do what they need to do. So like, if you need to have favorite ingredients, then add a favorite property to all your ingredients. Sometimes though, you can't do that as easily because a property might come out of the combination of two things. So maybe it's like a day of the week and an ingredient, and you have a favorite food for every day of the week, and they're different, right?
And Tuesdays is taco.
And Tuesdays is always tacos, because the best ingredient. I use tacos in all my taco-related things.
What's your favorite functional programming language?
My favorite language in general is Swift, and you can do a lot of functional type stuff in Swift because it doesn't constrain you in a lot of ways that Ruby does. So I guess I would say that. I could also talk about generics, because generic programming is something that you get in functional programming languages a lot. And it's not something that's implemented in Ruby, but you can approximate it with duck typing, which is kind of magical. But I didn't actually prepare an example for that, so maybe I should just call it a day, and that'll just be the cliffhanger for next time.
The ampersand period
Yep.
is called the safe navigation operator.
Also called the lonely operator, because it kind of looks like a,
I didn't know that thing.
it kind of just looks like a sad man just sort of sitting there staring at a rock, I guess. It's the lonely operator. Yeah. So I guess to summarize, like, we covered quite a lot of things. We covered like how do you, if you want to go from dealing with objects to dealing with functions, you can do that by grabbing methods off of them, right? And you can bind instances to instance methods sort of later in the future if you want to like maybe organize all of your processes up ahead of time and then apply them later. You know, you can reorganize the way that you do things just by grabbing at properties or methods directly. We talked about collections and how often we do sort of serialized processing of big collections of data, and we can use maps to be a shorthand for this kind of verbose way of iteratively doing things. And we sort of abstracted the idea of maps into other containers in general. You know, those could be files, it could be strings, and they could be even like, you know, containers of one object. And those could give us useful properties. And then finally, we talked about some data modeling stuff, like this is a product, and these sums in aggregation are, these types in aggregation are a sum. And this gives you useful ways of thinking about your data. That's a bit safer than just throwing around strings and numbers and stuff like that. So hopefully you learned something out of this, and hopefully you can apply this in some way in your day job or in your side projects. And you know, if you guys want to think about this some more or talk about this some more, feel free to grab me at any point and chit chat.